Welcome back to the Backyard Professor Math videos. I've been talking about distribution and factoring, and this has led inevitably to the idea of collecting like terms that are exactly alike with the variable, and the power of the variable is raised. X squared and x cubed are not like terms. They have to be both either x squared or both x cubed, etc. Now, when we have a term, 12z, let's say, or 1/2, I mean, plus 1/2 z plus 1/2 y, the theme here is the like terms need to be put together so we can either add or subtract them, and the unlike terms just simply hang out there, right? In this instance, we see this z and this z belong together, so we put them together with our grouping symbols, the parentheses. And now we can go ahead and carry out the operation. We have common denominators, which makes this relatively easy. So 1 plus 1 is 2, and we bring the denominator across. So this is 2 2's z plus 1/2 y. Well, 2 2 is just simply 1. We can leave the 1 out, so this becomes simply z, can't draw very good, plus 1/2 y. The idea is we want to practice putting like terms together and keep them alike. Now if we have, say, let's go with negative 8a plus 3b plus 9c minus 2a minus 10c plus 4b. Now see, here's an expression that just virtually goes all the way across the board. And it's okay, because we will have, I mean, face it, there are situations in life that you have a trillion different factors working all at once. Check out the universe, you know. You know what I mean? Our first expression that we need to do, the first step, I should say, that we need to do is put everything that is the same together in parentheses. Parentheses are our friends. Well, here we have a negative 8a. Let's start with a in the alphabet because it's the first letter. And we look here, there's a b, a c. We have a negative 2a. Are there any other a's? No, there's not. We're going to add all of these groups together. So let's start with the next one, which is a 3b. 9c, 2a, 2. We have a plus 4b. So we put the b's together. Then we look for the c. There's a 9c here. And we have a minus 10c here. Now, the reason we're doing this is in adding and subtracting, we can't combine either a negative 8a or a positive 8a with anything with b or c or q or f or x or z. It has to be the a's together. So we put them together. It has to be the b's together. The b's are the like terms. It has to be the c's together. Because it's addition, we can rearrange things like this. We got to be sure and keep the same signs when they're negative, however. Don't neglect the signs, whether positive or negative. And now it's just a matter of adding them together. So negative 8a minus 2a. Now, you remember, a negative 8a minus a 2a. We turn subtraction into addition by adding the negative. So we add the negative. So this is 8a plus another, or negative 8a, plus another negative 2a further. So this is negative 10a plus. Now once we solve what's in the parenthesis, we don't need to keep the parenthesis, right? 3b and 4b, that's easy. That's 7b plus 9c minus 10c. A smaller number is subtracting the larger number. 10 is 1 larger than 9. 10 has the negative sign, therefore this is going to be negative 1c, or just actually minus c. So the answer is negative 10a plus 7b minus c. Okay, let's do another one. This is fun stuff. It's important to practice these. It really is important to train our eyes, and the best way to do this is through practice, but we want to train our eyes on how to see the like terms, unlike terms, etc. And the very best way you do that is through practice. E minus 6e. Remember, any variable by itself is a 1. So 1e minus 6e is a negative 5e. You're understanding that by now? You're a smaller number taking a bigger number away. The difference between the two numbers is 5. However, the negative sign resides with the bigger number, so it's going to be a negative in the answer. And it's the same if we have e minus 3m. It doesn't matter what variable. It really doesn't matter what variable. These had a common term, so we could subtract them. But are these the same? No, they aren't. E minus 3m cannot be simplified. That is the answer, because there are no like terms here. That makes sense? And then we have 14d, and we put together 3d with it, and we add 9 to that. So we have two terms with a common term factor, a like term, the d and the d, and then we simply have a numerical coefficient. What do? We combine the like terms. I like to use the parenthesis. I promise later on you will want to use parenthesis all the flipping time. So 14, 15, 16, 17d. 17d. We can't forget the plus 9, but we cannot add 9 to 17. No. That is as far as you can take this. If the 9 had a d, you could, but it doesn't, so you can't. This is the answer. You simplify by adding like terms within the group, but then the extra term just follows along. That is the proper answer. It's important to recognize this. You can't just simply add everything. They must be alike. The same thing when we're given an expression 9c, and let's say 3f, and let's say minus 3c. Now we've got a couple of terms that have the like terms. The c, the f is the oddball out, so we want to group the two c's together. 9c minus 3c. We want to put them together in the parenthesis because they are proper like terms, but we can't just ignore the 3f. It's part of this equation, so we have to bring it along for the ride. Now 9c minus 3c is 6c plus 3f. C and f are not like terms, so that is as far as you can take that equation. You've added the like terms. Technically, you've subtracted the like terms, but you've put them together in a group. You still have that expression out of the original expression, so that's got to be part of your answer, but you cannot add those together. You cannot make those 9CF. Not by adding. No, no. Multiplying you could, but not adding. They have to be exactly alike with their variables. That cannot be overemphasized. I promise. That is critically important. So let's say we have S plus SR plus ST plus SU. With the common factor, we can see we can pull out automatically is s. So we factor out s, and that leaves us 1, because s times 1 is 1. You have to have that 1 there for that s, plus r plus t plus u. And then you can put that back in. S plus sr plus st plus su is that. So that's kind of a simple statement. Now, let's say we have minus 2x. Well, I got to write better, huh? Minus 2x plus 3y minus 9xy plus 4y minus x plus 11xy minus 8. Now here's another example where the variables are mixed in throughout with adds, subtracts, and so on and so forth. So what we want to do is we want to pull all of the like terms together. It makes it easier for us to do. Remember, everything in math, believe it or not, is made so that it's easier to do. Our parentheses are our friends. Let's put together all the x's first. Negative 2x, there's a y, xy, a y, oh, there's a minus x, and then a xy, and then 8. So there's one term. Let's put the y's together. 3y, there's an xy, oh, there's a 4y right there, plus 4y, there's an x, and there's an xy, and an 8. So the y's are together. And now let's put together the xy's. A negative 9xy, yx, xy, plus 11xy, and then we can't forget the minus 8. Now that we have them all together in like terms, now we can add, subtract, put them together in any way, and we'll get an easier answer. Do you see how, using parentheses, putting all the terms together in like terms will simplify this? It'll make it so that we eliminate errors. Yes, it takes a little longer to do this. We're not after speed. We're after accuracy. We want to arrive at the right answer. Negative 2x minus x, which is a plus minus x, is negative 3x. You don't have to have the parenthesis after you solve what's in the parenthesis, so we can leave them out. Plus 3y and 4y is 7y. Plus negative 9xy plus 11. Now the difference between, see, this is plus 11. We can rewrite this. Because it's addition, we can switch these around and not affect the, we got to keep the signs, but here we have a positive 11xy, so we can put that out front. There's our positive xy, and then a negative 9xy minus 9xy. The terms are alike, so what's 11 minus 9 is 2xy. See how that works? That's one way to do it. And then, of course, you can't forget your negative 8. And there is your answer, because we've combined all of the like terms that are in this great big long cotton picking equation. We've combined all our terms, we've added, subtracted, and all that, and put them together, and then we have the negative 8 up front. The negative 8 doesn't have any kind of a variable with it, so you can't subtract that from any one of these others. It's not a like term either. So that is your answer. And that's how that works in algebra. Very important to get that. Now, there's another important feature in algebra that I want to use as kind of a red alert in your mind. Whenever you see this situation, I'm going to embarrass the heck out of myself by showing you this, but if we have negative we have negative 4 plus a. And you know how I told you denominator down to make you convinced denominators are down? Here I'm going to go, danger, Will Robinson. Danger, Will Robinson. You remember the old Lost in Space? I'm giving my age away, aren't I? Danger, danger, danger. Here's what I want you to drill in your mind of why this is dangerous. Because it's critical that whenever you have a simple negative in front of a grouping symbol like this, the negative has to be distributed into each term in that parenthesis. The process of distributing that negative into the parenthesis is going to change the signs of everything in that group. And if you don't do this, you're not going to get the right answer. What this is showing is there is an implied -1 in front. And that's always implied. We will see thousands of equations that do this, and we'll practice many of them here so that you can see this. What this does is we distribute the -1 into the parenthesis. So -1 times 4 makes that +4 a -4, and -1 times +a makes that a -a. Can you see the difference? Up here, it's +4, +a. When we distribute the negative, a negative times a positive is a negative times a positive is a negative. This will show up a lot of times. So if we have a -3 minus a plus b, we distribute this negative, implied -1 into each term. Negative times a positive makes that a -3. You change the sign in front of the a to +a. You change the positive sign in front of b to negative, because negative times positive is negative. Negative times negative is positive. Negative times positive is negative. And that's why it changes the signs within the group. You really want to keep your eyes peeled for a negative sign in front of a parenthesis, or a bracket, or a brace. And I'll show you those here in just a little bit. Don't worry about those at the moment. Let's show you some other things. What if we had 2 minus 6 plus a minus 9c? Now we have a 2 out here, but we're still subtracting everything in this group, and there's a -1. This is in reality 2 minus 1 times 6 plus a minus 9c. That's what this is. We don't distribute the 2, but we do distribute that -1 into every term. So let's do that. We keep the 2 out here. The 2 comes along for the ride. -1 times 6 is -6. -1 times a is -a. -1 times -9c is positive 9c. You see how that changes that? And now we can carry out our operations. 2 minus 6. 6 is the bigger number than 2. The difference is 4. But 6 has the negative, so it's going to be a -4. Minus a plus 9c. You can see there's no more like terms. The two numbers can be added or subtracted. We got -4. A is not C, so this is your final answer. That's as far as you can take that. Okay, let's do another one. What if we're given 9 plus 1 minus 6 minus 2? Let's say we're given this. Now here we have two different groups. One group is being subtracted from the other group, right? So here's how this works. You go 10 minus negative 1 times 6 is 6. Negative times a negative 2 is a positive 2. And now you work from left to right. 10 minus 6 is 4, plus 2, the answer is 6. You see how this negative out here changes everything to give you the correct answer. That is simply how that works. This also works, now I've been showing you numbers, but it also works with variables as well. Let me show you the variables. Let's say we have AB plus CF minus QR plus 8A. Make that a little clearer. So now we have a first group subtracting a second group. How do we do this? We look for common themes. We look for like terms. There's no like terms here, so we can simply copy these out. We don't have to include the parenthesis. They're just there to show this is the first group, this is the second group. Now that we know there are no like terms, we can simply write out the terms AB plus CF minus a minus QR. Negative times a negative is a positive QR. A negative times a positive is a negative 8A. And I do believe that's the answer. There are no more like terms here, so that is your full answer of that equation. That's how that works. Now we're going to, what I want to do, I think I've got time for just a couple of more. Yeah, I'm getting close, darn it, I lost my clock. Let's say we have a negative 2x plus 7. A negative times a positive is a negative 2x. A negative times a positive 7 is a negative 7. You see how that negative works? Let's say we have a negative 100x plus 61. We distribute the negative in. That's going to be a negative 100x. Negative times a positive is negative 61. It changes the signs in those parentheses. We have a negative 41 minus x. Negative times a positive 41 is a negative 41. And a negative times a negative x is a positive x. You can see now why we wanted to practice positive and negative numbers early on in algebra, can't you? Negative n minus m equals negative times a positive is a negative. Negative times a negative is a positive. That's how that works. We have a negative 4a minus 3b plus 7c. We distribute this negative into each term. That becomes negative 4a. Negative times a negative is a positive 3b. And a negative times a positive is a negative 7c. You can see how to do these negatives, can't you? Let's see, do I have time? I think I've got time for... Oh, heck, I better call it good. Otherwise, I'm going to have to just take these out. My point is, we're learning more and more properties. We still have some, we have some square roots, radicals to do. And as we learn several more operations, we are combining all of the operations into various types of ways. We're learning little tricks on how to do negatives and positives, add, subtract, multiply, divide. All of this begins to be put together in all the different kinds of equations. And we want to practice those equations so that we can become familiar with them. This is going to open up the vast realms of algebra to us. So in my next video, this has led automatically to the next feature in algebra that is absolutely the terror of students, and I am going to completely eliminate the fear or the disgust or the hate of this next part of algebra for you, and we'll do it step by step. When it was shown to me step by step, man, it opened up my mind to the greatness, the power, the joy, the real down-to-earth, damn, this is fun kind of math. So thanks for watching my videos. Happy calculating. Have a great life. And I will see you in the next video.